Welcome to a lesson with Dr. Powell. Let's take a look at the distributive property of union and intersection in power sets. So let's suppose we think of a function defined in this way, like A intersects something. Now, intersecting something with A means like ignoring anything that's outside of A, which is the same as a blockout map using blocks. Now, blockout maps are the only way that you can, are the way that you get merges in the power set that preserve the structure of union and intersection. That means that intersecting actually preserves unioning. So if we take something and map it to A intersect that thing, let's think what that means that we're going to preserve the structure of union and intersection. In particular, why don't we look at this? A intersect B union C. So if it preserves structure, that means that the output of this is going to be A intersect this, and then union A intersect that. So it's kind of like the image of B, and then like the image of the union, which is, again, we can consider as union, and then the image of C, which is A intersect C. So we have this nice distributive property based upon structure preservation of merging here in a power set post set. So we have A intersects something would be just like this, and likewise we have a very similar notion. A union something like B intersects C carries over with the same idea. A union B intersect A union C. So this is kind of funny because you have both of these operations distribute over each other. Now, if you think about multiplication and addition, both operations do not distribute over each other, only multiplication over addition. But these two operations do. So if oftentimes people try to use the symbol multiplication for intersection and addition for union, and that's great, but it takes away the idea that you can actually distribute this guy over that guy too, and you can interchange and think of it as times and plus. So, I mean, in either case, you could think of this as times, you could think of this as plus here, or you could think of this as times, and you can think of this as plus, and look at the result. Here you have plus, here you have times and times. So it's like this distributing over that sum. Here you could also think of plus right here and multiplication. It works both ways just fine. Very useful idea that will be very needed when we're looking at Boolean algebraic expressions. Thanks for watching.